In this video, I'm going to look at more techniques of integration. In particular, we'll focus on the trigonometric substitution. And here I have three triangles. I'm going to call the first one there case 1, the second one case 2, the third one case 3. So basically, you're solving integrals where you have a radical. In case 1, it'll be of the form a squared minus u squared, or that could be a squared minus x squared, where a is a constant and of course u will be the variable. So you can see the three setups in each scenario there. Notice at the bottom of the triangle we have sine theta, secant theta, tangent theta, and notice it's all u over a, u over a, u over a. So that'll help you remember what the setup will be in case you're taking a test and you're not allowed to use your notes or whatever. So notice for the first one, sine theta is the opposite over the hypotenuse. That would be u over a. So from that scenario, you should be able to find the third side. Okay, so if you forget whether this should be a squared minus u squared or u squared minus a squared, you can get it from the Pythagorean theorem. All right. So for example, say it's, it's this setup because sine is opposite over adjacent. So this side, say, will be, we'll call it y. So that means that a squared hypotenuse squared should equal to the sum of the squares of the other two sides. So this would be u squared plus y squared. So if you solve this for y squared, you'll get a squared minus u squared equal to y squared. So from that you can see that y, taking the square root of both sides, y will equal to the square root of a squared minus u squared, and you get this side. You can do the same thing over here. If it turns out to be case 2, then secant theta will be u over a, and secant is the hypotenuse over the adjacent. And from that you can get this using the Pythagorean theorem. Tangent theta is opposite over adjacent, and from that again you can get this. Okay. So basically you're going to use one of these substitutions whenever you have an integral that has this radical expression. Okay. The square root of some constant squared minus a variable squared, or the other way around, or the sum of a variable squared plus a constant. In some cases you might have to use another u substitution, or your standard u substitution, to put it in one of these particular forms. Okay, the one I'm going to look at today. Okay, so if we look at this one here, it's the antiderivative of 1 over x squared square root of 9 minus x squared. Okay, so notice in this particular case, to use a standard u substitution and letting u equal to 9 minus x squared, I would have to have a factor of x, say, up here. I don't have it. I have an x squared down here, and even if I had the x squared in the top, again, the same sort of thing. That's this procedure just went through the u substitution. The standard u substitution is not going to work. So in this case, the best option for this integral is scenario 1. Okay, so if you look at this, in this case, instead of u, I have an x, but it's the same thing. I put these in terms of u because sometimes you will have to use a regular u substitution before you attempt this type of solution. Okay, so here you have a squared would be 9, so a would be 3. X squared is u squared. Okay. So it's in this form right here. Okay. I got the x, or the u, and I got the a, which is 3. So now I'm going to use the first substitution here. Sine theta is equal to u over a. So I would set up this triangle right here. Okay. You always want to set up this triangle right there if you're using the case 1. So sine of theta is u over a. Set it up. And then we go on to the substitutions. Okay, So in this particular case then, here it is, x, okay? Instead of u, I'm using x because the variable is given in terms of x. So x is equal to 3 sine theta, okay? So that's this step right here. U equal a sine theta. In my case, I have x equal to 3 sine theta. That's going to be the main substitution. So now the object then is going to be to take this integral and transform it in terms of an integral involving theta, d theta. Some constants will be involved also, but this is your main substitution, x equal to 3 sine theta. So taking the differential of both sides, this will be dx, the root of sine is cosine, and then you have your d theta. Okay, so then all we're going to do then, I'm going to make the substitutions, except I'll do it down here for x, and x over here, and for dx, okay? So let's do it for the denominator first. So I have in the denominator, I have x squared, square root of 9 minus x squared. So all I'm going to do is where I have an x, I'm going to put 3 sine theta. Okay, so there's an x, 3 sine theta squared. And then in the radicand over here, it'd be 9 minus x squared. X is 3 sine theta squared. There it is. I go through the procedure and square it, and I get this. Okay, 9 sine squared x, square root of 9 minus 9 sine squared theta. And then I just simplify this. Okay, so now I get over here at 27 sine squared, square root of 1 minus sine squared. So all I did there is right here in this radicand, I factored out the 9. So this would be 1 minus sine squared theta. Okay, and then I said, okay, the square root of 9 is 3, so that comes outside, and the 3 multiplies this 9 right there. That's how I got this 27 over here. And then 1 minus sine squared theta, okay, 1 minus sine squared theta is the same thing as cosine squared. Okay, so I made that substitution in here. Okay, and that's, remember, this is the square root of that. I already took the 9 out. And the square root of cosine squared is cosine. That's why I got this cosine over here. Okay, so here's the substitution I used. You have your one of your basic identities from trig, cosine squared theta plus sine squared theta is equal to 1. So that tells me that cosine squared is equal to 1 minus sine squared theta. Okay, so right here again, I factored out the 9, and that left me with the square root of 1 minus sine squared theta, which is cosine squared, and the square root of cosine squared is cosine. There you have it. Okay, then I go to the integral over here and say, okay, now just make your substitutions. Okay, using what I have over here, dx, right here, dx is replaced by 3 cosine theta d theta. Okay, and then this x squared times the square root of 9 minus x squared, okay, that I did right here. So this is then going to be doing the replacement there. Again, all of that, 27 sine squared theta cosine theta. Okay, so now we set this equal to, and then we simplify. So cosine and cosine cancel out, divide out to be 1. 3 goes into 27 9 times. So that's 1/9 that's left out. I'll take that out in front here. This will be 1/9. The integral of, so what do we have left here? 1 over sine squared theta d theta. Okay, and then we can rewrite this using your trig identities again. 1 over sine squared theta is the same thing as cosecant squared theta d theta. Okay, so now I want the integral of cosecant squared theta. That's one of your basic integrals for trig functions. This is going to be 1/9. And the integral or the antiderivative of cosecant squared theta is minus cotangent theta. And then you have your constant of integration. There you have it. So this is going to equal then to minus 1/9 cotangent theta plus c. And just like in the regular U substitutions, you always go back or write your answer in terms of the original variable, and that's x. Okay, so all we need to find here is what is cotangent of theta, and that's where that little triangle comes into play. Okay, so let me just do it here as a reference. Right triangle here. So sine is x over 3, and then this side, remember this was the square root of 9 minus x squared, and then this is theta. So all I have to do then is say, okay, I want negative 1/9, and I want the cotangent of theta. So all you're going to do is go to this triangle here and say, okay, cotangent of theta is the adjacent side over the opposite. So this then should be the square root of 9 minus x squared over x plus the constant of integration. Okay, so this is your answer. Okay, now if it turned out that your answer over here, instead of a cotangent of theta, it had a cosine, then you go over here and say, okay, cosine of theta is the adjacent over the hypotenuse. So you write this as the square root of 9 minus x squared over 3. Okay, but this little triangle right here, once you get the integral in terms of theta, you're going to use this little triangle to finish it and give the answer in terms of x. Okay, follow up with another video concerning these types of integration problems. So thanks for watching. We'll see you next time.